Hello everyone. This is again permutation and combination part 2. Okay. In the last section we studied about the basics of permutation. Okay. Listen carefully. When we care about the order, it is the permutation. Okay. When we care about order, okay, it is permutation. Listen carefully, read carefully, and listen my last video carefully. In that many things I told about how to identify this problem is about permutation. Okay. Now we are studying the permutation. Okay. So we know that used permutation formula here. Okay. But in exam we have to identify the question is on permutation or combination. Okay. Then we have to apply the formula. Okay. In the question paper, there is not mention anywhere use permutation here, use combination here. We have to identify where we can use the permutation, where you can use the combination. Okay. So that I already told you, if there is a arrangement word, then use the permutation. Okay. And if there is a selection word, there is a combination. Use combination. Okay. And one more clue point is, when we care about the order, it is a permutation. Always it is a permutation when we care about the order. Okay. And when the order doesn't matter, that is combination. When order doesn't matter, there's a combination. Here order matter. Okay. Whenever we will start the combination, I again told you how to identify the combination. Okay. Now back to the point. See, suppose 472. Okay, there are three numbers, 2, 4, 7. We have to form one number from these three numbers. Okay, so here I write 2, 4, 7. Meaning change. Okay, number change. This is a 247. This is a 472. So the order mattered here. Okay, the order mattered here. Or we care about the order here. Okay. For again, second example, suppose lock, number lock. Traveling bag has a number lock. Okay. So there also order matter. If I lock on 1010 and if I put 0101, then lock will not open. Okay. So order matter in the permutation. Okay. Now we will go to the next step. Permutations. There are two types of permutations. Okay. First type is a permutation with repetition. Okay. See, in the lock system, we can repeat 333 code. We can repeat 1 0, again 1 0. Okay. So this is the repetition. So permutation with repetition. And second one is no repetition. No repetition means, suppose in a running race, okay, you can't be first or second. You may be first or maybe second, maybe third. Okay, but you can't be first, second, third. Okay, so repetition is not allowed here. Okay, this is the second type. Okay, now See, it is very simple to calculate when a thing has n different type. When thing see, permutation with repetition, in that first is when a thing has n different types, we have n choice each time. Okay, n choice each time. How it is? It means what? It means what? Means, see carefully, means n possibilities. For first choice, getting or not? Okay, n object. Okay, so we have n object, we have n choices each time, n possibilities for first choice. Again, if repetition is allowed for the second choice, again we have n possibilities. Because, why? Because here repetition is allowed. Okay, so we conclude here. What we conclude? N into n into n up to dash dash, suppose r times. So I write here n raised to r permutations. Okay, so formula for permutation with repetition is n raised to r. Okay, remember this formula when repetition is allowed. Clear? Take a screenshot. Again I repeat here, when we have n things, different things, and we have n choices for each time. Okay, n possibilities for the first choice, for the second choice also n possibilities, and for the third time n possibilities. Okay, dash dash dash, so on. I write here so on. Okay, that's why formula is n into n into n into n up to r times. R time means what? N raised to r. This is the formula for permutation with repetition. See the example of repetition. What is the example? In how many ways 4 letters A, B, C, D can be arranged taking 3 at a time? Okay, in a banking exam, permutations and combination examples always ask. Okay, see what is the answer here. There is no restriction, there is no if condition. Okay, there is no such a that word, so restriction is not here. Okay, so restriction is not here means what? With repetition. Clear? So permutation is n raised to r. What is the n? N are the number of objects. How many objects are there? 1, 2, 3, 4. So n equal to 4 and taking 3 at a time means r equal to 3. So our answer is, it is 4 raised to 3. So it is 64 ways. Clear? Take a screenshot. Okay, first one is what? Object can repeat any number of times. First object can repeat any number of time. Okay, and the second one is distinct object. Okay, distinct object with repetition. Distinct object. How it is? See, the second type is the total number of mutually distinguishable permutation. The total number of mutually. See the second distinct object. The total number of mutually distinguishable permutation of n things taken all at a time of which P is one type and Q is another type, such that formula is for permutation with repetition is P plus Q equal to n is n factorial upon P factorial into Q factorial. This is the formula. Okay. For the first one, formula is n raised to r. And what is this? This is the object can repeat any number of times. For this, n raised to r. And if there are distinct objects but repetition is allowed, then use the formula n factorial upon P factorial into Q factorial. Take a screenshot. I will explain by using the example. Okay. Example. Okay. It was asked in a university paper. See, 6 coins are tossed at a time. Imagine 6 coins. Okay. 6 coins are tossed at a time. Okay. How many outcomes shows 4 heads? Okay. Shows 4 heads. And 2 tails. See here, there is a no if condition, there is a no such a that, it means what? There is a no restriction. So it belongs to the first type. First type is what? Permutation with repetition. But in that, it is in the second type. Okay, how it is? Distinct object. How distinct object? See, 4 heads. It is a one type. Okay. And the 2 tails, it is another type. They are distinct in nature. Yes, it is a head, it is tail. So they are distinct. Okay. So we treated it as a P, it as a Q. It is P and Q. And by using above formula, this formula, I write here P plus Q equal to N is n factorial upon Q factorial into P factorial. So n plus Q is 6. So my n is 6. See here, 6 coins. And 4 plus 2 is 6. Okay. So put value in the formula here. 6 factorial upon 4 factorial into 2 factorial. Okay. Now solve this. We already know how to solve this. Now factorials problem. See, here 6 is there. So 6 keep as it is. Write down 5. Okay. Then 4 factorial as it is. Because in the denominator there is a 4 factorial. This also keep as it is. Write down 2 into 1. This and this will get cancelled. This is what? 3. So what we get here answer is 5 3s are 15. Clear? Okay, take a screenshot. This is the first type. Now, second type. What is the second type? As a regular type. It is a permutation without repetition. And here we use the permutation formula. Okay. It means what? Without repetition means what? Choices reduces. Okay. Every time, every chance, at every time the choices are reduces. Okay. Choices get reduces. Choices are reduces. Okay. Each time. Okay. So we have a formula NPR equal to n factorial upon n minus r bracket factorial. Okay. In the last session we already studied this formula. So this formula is for what? Without repetition. This formula is for what? With repetition, but object can repeat any number of times. Okay, this is for with repetition but for the distinct object. Okay, clear? All three formula are very important. Take a screenshot and solve the problems. Okay, collect the problem from university questions and solve it. See the example. Find the number of different 4 letters words with or without meaning. With or without meaning that can be formed from the letters number. See the number letter N-U-M-B-E-R. How many? 1, 2, 3, 4, 5, 6. So here number of object, I write shortcut, number of objects are n equal to 6. And what is the condition here? With or without meaning. Okay, so we use the second formula here, permutation regular formula here. And how many letters we have to choose here? We have to choose the 4. Find the number of different 4 letters word. We have to choose the 4. Means what? N-U-M-R, 4. Okay, this type of combination, M-B-M-E-R, this type of combination from this set. Okay, so we have to choose 4 at a time. So R equal to 4. Clear? So there are 6 letters in the word number. So the number of 4 letter words equal to the number of arrangement of 6 letters taken R at a time. R means 4 at a time is 6p4. So what is 6p4? 6 factorial upon 6 minus 4 bracket factorial. Okay, 6 factorial upon 2 factorial. Okay, now 6 into 5 into 4 into 3 into 2 factorial. 2 factorial. This get cancelled. Take a product of this 4 number. It is 360. Clear? This is the required answer. Take a screenshot. See the next example. How many different permutations can be made with letter algebra so that A alphabet will not remain together? Okay, will not remain together. This question was asked in a banking exam. Okay, see, we solve it conversely. First, we solve A will remain together. Okay, first we solve A will remain together. How it is? See, there are 2A. Okay, in algebra word there are 2A. So I write here 2 A's will take 1 unit, means 1 place. 1 unit means 1 place. Unit. And if I take bunch of A, then what remaining? L, G, E, B, R. See, 1, 2, 3, 4, 5, 6. Means what is remaining here? 1, 2, 3, 4, 5. 5 alphabets are remaining. So I write here 5 letters. Remaining 5 letters. Okay. Remaining 5 letters. I write here. Means you will understood what I do here. This is a 1 bunch. Okay. Remaining L, G, E, B, R. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Remaining 5 letters will take 5 unit, means 5 places. Okay, 5 unit. Total is what? 6. 1, 2, 3, 4, 5 and 6 unit. Total is 6. How 6? This is treated as a 1. So I write here 6. 1, 2, 3, 4, 5 and 6. Okay. See the arrangement. Arrangement is, how we can arrange? We can arrange it by 6p6 ways. Okay, 6 alphabets by 6 means n equal to 6. Taken 6 at a time. So it is a 6 factorial. And what is 6 factorial? 6 factorial is 720. Okay. Now, without condition. Without condition, I write, what we write here? Without condition. Without condition means what? How many letters are there? 1, 2, 3, 4, 5, 6, 7. 7 means n is 7. Okay. And a is 2a. So remaining alphabets are 5. So I write here 7p5. 7p5 means what? 7 factorial upon 7 minus 5. 7 minus 5 factorial. So it is 7 factorial upon 2 factorial. Okay. 7 factorial upon 2 factorial is 7 into 6 into 5 into 4 into 3 into 2 factorial. Upon 2 factorial will get cancelled. And the product of this is 25, 20. Clear? Okay. Now question is, A will not remain together. So I write here the required what is the condition? A will not remain together. Okay, remain together. So for that I use a trick. What is the trick? This is A will together. Okay, so answer is 720 and without condition answer is 2520. So I write here 2520 minus 720. So remaining is 1800 ways. 1800. Well, this is my required answer. Okay, clear? Take a screenshot.